Okay, so let's talk about integration by parts. This is the final tool you need to be able to integrate anything that can be integrable. So remember the product rule from differentiation. So if you had fg prime, that's equal to f prime g plus fg prime. Remember this from the product rule. Now, integration by parts, the formula is usually given in terms of u and v, but u and v are just f and g, so it doesn't matter. But let's write that f and g in terms of u and v. So I'm doing the exact same thing. I'm writing uv all prime is equal to u prime v plus u times v prime. Okay, so what can we do? Let's integrate both sides. So when you integrate both sides, you integrate this, and you integrate this. Well, uv prime and then integrate. It's like differentiating something and then integrating it. Well, when you do that, you just end up getting the function that you started with. So that's uv. That's equal to, now we leave this how it is. So we write that as u prime v plus integral of u v prime. And then what we do is we bring this to the other side. So we're left with uv minus integral of u prime times v is equal to integral of u times v prime. Now, the thing is, the formula is usually given like this. So like this is the final formula. But remember, u is a function in terms of x. So u is equal to something in terms of x. And v is also equal to something in terms of x. It's a functions, right? So another way to write this is equal to the integral of u. V prime is just dv by dx as a derivative of v with respect to x. And that is equal to, well, you have uv, so just write that u and v, minus the integral of v, and then u prime is just derivative of u with respect to x, so you write that as du by dx. Now this might not make a lot of sense right now, but let's say I ask you to integrate something like 2x times sine of x dx. Now what do we know so far? We know the reverse power rule, and we know integration by substitution. And none of these would work, because what can you even substitute in this right here so that integration by substitution would work? There's really nothing you can do. So now this is the reverse product rule, because now we have a product of two functions. So we have the functions 2x, and we also have the function sine of x. Let me draw that better. We have 2x, and then we have the sine of x is the other function. So if you compare, you can write 2x sine of x and u dv dx. Well, how do I know what is u and what is dv by dx? So this is how you usually choose u. So u, you do this, it's called LIATE. This is just like an acronym for, I'll show you right now. LIATE. This is logarithmic functions. This is inverse functions. This is algebraic functions. So like x right here that we see. These are trig functions. And these are exponential functions. Exponential. So we choose u to be whichever the first of these is. So in our case, we have 2x and we have sine of x. Well, 2x is an algebraic function, so this is 2x. And then sine of x is a trig function, so this is sine of x. So what we do is, we let u equal 2x. So let u equal 2x. That means our dv by dx is going to be sine of x. So we have dv by dx is equal to sine of x, right? Of course, because if u is equal to this, then we're left with du by dx, which has to be equal to that. So now we need two more things. We need du by dx, because we're going to use this later on. So it's better to have everything that you need first before you start using the formula. Because we're going to have du by dx here. So we need du by dx, which is just 2. And then we need v as well. Well, v is just the integral of the sine of x. That's pretty simple. That's just negative cosine of x, right? That's a very simple regular integral. So now we have everything we need to actually apply the formula. So the integral of 2x sine of x is equal to the integral of u dv dx, which is equal to uv. So we have u times v. So we have 2x times negative cos x. So we have negative 2x cos of x minus the integral of v, which is negative cos x, times du by dx, which is positive 2. Of course, with respect to x, right? And now look, this is negative 2x cos x, so we're done with that. And now this negative becomes plus 2. You can bring the 2 outside because it's just a constant, right? And you have the integral of cosine of x dx. And this is very simple. We know what the integral of cosine of x is, right? That's just equal to the sine of x. This is one of the simple integrals, equal to sine of x. And that's it. That's all we really needed. So now we have that is equal to negative 2x times the cosine of x plus 2 times the sine of x plus c, of course. And that's your final answer. And you can see that it works. So let's differentiate this right here, right? We're going to find dy by dx. And that is equal to, well, let's use the product rule because, of course, that's how you differentiate a product of two functions, right? So we have negative 2x cos x. So if you differentiate that, you get negative 2 cosine of x plus, and you have negative 2x, and the derivative of cosine of x is equal to negative sine of x. So we have that plus 2 times the derivative of sine of x is cosine of x. Well, you can see this and this will cancel each other out, and negative will make a positive. So you'll be left with 2x sine of x. And that is what we started with. We started with the integral of 2x times sine of x dx. And that's exactly what we ended up getting. So you can see that the integration by parts helped us to integrate a product of two functions, one of which is actually the derivative of another function. So if you just see this formula right here, you have to kind of memorize this formula because it is very helpful, but you can always derive it by yourself. You just look at the product rule. This is very simple to memorize. This is very, very simple. You take the derivative of one function, leave the other function as it is, and you add that to the first function, however it is, plus times the derivative of the second function. From there, you just integrate, and then you end up getting integration by parts rule. And then to choose u, well, you use this right here. This whole thing right here. It's called LIATE because it's like an acronym to remember, LIATE. And you can see, you let u equal whatever the first of these end up being. So in our case, we had 2x and sine of x. 2x is algebraic and sine of x is trig. Well, algebraic comes before trig in this case, so we let u equals 2 of x, and then we let dv dx equal sine of x. And then from there, we find du dx and we find v, and then it becomes very simple, and we just take regular integrals, and we end up getting our answer. So let's do an example question, and it'll make even more sense. The constant a is such that the integral, the definite integral between 0 and a of x e to the negative 2x dx is equal to 1 over 8. Should the a is equal to a half ln 4a plus 2? Okay, this is a very nice question. So, remember, LIATE, right? By the way, first you have to realize this is integration by parts because it's a product of two functions. We have x, and we have e to the negative 2x. Those are our two functions. So we have LIATE. Well, clearly e to the negative 2x is exponential, so we have e to the negative 2x. And then x is just algebraic, so this is x. So that means our u is going to be equal to x. That means our dv by dx is going to be equal to e to the negative 2x. Okay, before we start using the formula, let's find du by dx. That's just 1, because if you differentiate this with respect to x. And then let's find v, and that's going to be equal to the integral of this, which is negative e to the negative 2x divided by 2. So now we have all that we need. So let's start using the formula. So the formula says you do the integral of u dv dx is equal to uv minus the integral of v du dx. Okay, let's start then. So we have u times v, that's x times negative e to the negative 2x divided by 2. So we have negative x e to the negative 2x divided by 2 minus the integral of v, which is negative e to the negative 2x divided by 2 times du by dx, which is just 1. So that's it. That's right there. And this is, of course, with respect to x. Now what do? Well, negative becomes positive, and we can bring the 1 over 2 outside. So we have negative x e to the negative 2x over 2 plus a half times the integral of e to the negative 2x dx. Well, we already know what this is, right? We can calculate it again, but we know the integral of that is just negative e to the negative 2x divided by 2. So now we have negative x e to the negative 2x divided by 2 plus a half times negative e to the negative 2x divided by 2, which is equal to, well, let's factorize it, right? So you have e to the negative 2x divided by 2. This is the good thing with e, you can always factorize the integral to the end. Then you have negative x plus, and you're going to have a negative a half, I think. So let's make the negative right here. You're going to have positive x plus a half. Is that correct? Negative x e to negative 2x divided by 2. Negative x e to negative 2x divided by 2. Minus e to negative 2x divided by 4. Minus e to negative 2x divided by 4. So yeah, that's it. That's our answer right there. But now what do we need to actually do? We found the integral. We need to put in the limits and see, and it's telling us the answer is going to be 1 over 8. So if you evaluate this between a and 0, then you should end up getting 1 over 8. So let's do it, and then we have to find the value of a. It actually tells us what it is, we just have to like show that it's true. So let's try. So you have negative e to the negative 2a divided by 2. I'm just putting a in for x over here. And then you have a plus a half. And you have all that in brackets. And then from there you subtract. When you put 0 in here, you get e to the 0 is just 1. So you have negative a half times 0 plus a half. So you have negative 1 over 4. And that is equal to 1 over 8. Okay, so what can we do? We can rearrange. So this is negative, negative. So that's a positive a quarter. I bring that to the other side. So we have 1 over 8 minus a quarter. So we have negative e to the negative 2a. And I'll write this as 2a plus 1 divided by 2 is equal to, I know this is divided by 2, I'll just bring 2 to the other side. So we have 2 times 1 over 8 minus 1 over 4. Okay, so what's that? So we have negative e to the negative 2a times 2a plus 1 divided by 2 is equal to 1 over 8 minus 1 over 4 is just negative 1 over 4, or negative 1 over 8, and then that times 2 is just negative 1 over 4. So we have negative 1 over 4. Well, we can get rid of the negatives, right? Because it's negative here and negative here, so we can make that positive. We can make that positive. Okay, so far so good. Now we can multiply this by 2, right? So we have e to the negative 2a times 2a plus 1 is equal to 2 over 4, which is a half. Okay, and that's all we can do with just regular manipulation. Now we need to use the natural log because we need to get a on its own. So how do we do that? Well, let's take the natural log of both sides. So we have ln of this whole thing right here. That's ln e to the negative 2a plus 1 is equal to the ln of a half, which is equal to negative ln 2, right? What do we know? This is ln a times b, which is ln a plus ln b. So that is ln e to the negative 2a plus ln 2a plus 1 is equal to negative ln 2. Now what do we do? Well, ln e to the negative 2a, we can bring negative 2a over here, negative 2a, and then ln of e, which is just 1, so we have negative 2a there, plus the natural log of 2a plus 1 is equal to negative ln 2. Now what do we need to do? We need to get to this form right here, a half ln 4a plus 2. Okay, how do we do that? Well, ln 4a plus 2. So what we can do now is we can bring this 2a to the other side. So we have ln 2a plus 1 is equal to 2a minus ln 2, right? Yep, we have that right there. Okay, and now what can we do? Well, we just need to rearrange more. So we have ln 2a plus 1 is equal to 2a minus ln 2. Let's leave 2a on its own. So then you'll have ln 2a plus 1. Bring the negative ln 2 to the other side. So you have plus ln 2 is equal to 2a. Well, this is again ln a plus ln b. So if you just multiply them, you end up getting ln a times b, which is ln 2a plus 1 times 2 is 4a plus 2. And that's equal to 2a. And then you've got what you need if you divide by 2. So you have a is equal to a half times ln 4a plus 2. And that is exactly what we needed to show right here. A is equal to half ln 4a plus 2. So yeah, that's integration by parts. This is probably the most important form of integration because most of the times you're not just going to be able to ask the integral of cosine of x, right? That's very easy. But as soon as I say an integral of sine of x, cosine of x, well, this is interesting because now you can do it two ways, right? You can do it by integration by substitution. And when you get the answer for that, which is equal to sine squared of x over 2 plus c, try using integration by parts and see if you end up getting the same answer. Actually, I might make a short video doing that by integration by parts. So yeah, I hope you enjoyed the video. If you did, please like, share, comment, and subscribe, and let me know what else you want to see in future videos.